Concept of risk. In this video, we are going to see about concept of risk. Risks are those events or conditions that may occur and whose occurrence, if it does takes place, has a harmful or negative effect on a project. Risks should not be confused with events and conditions that require management intervention or action. A project manager must deal with and plan for those situations that are likely to occur but whose exact nature is not known beforehand. Such situations, however, are not risks. For example, it is almost certain that defects will be found during software testing, so a reasonable project must plan to fix these defects when they are found. Similarly, it is almost certain that some change requests will come, so project management must be prepared for changes and plan accordingly to handle such normal events. A risk, on the other hand, is a probabilistic event. It may or may not occur. For this reason, we frequently have an optimistic tendency to simply not see risks or to wish that they will not occur. Social and organizational factors also may stigmatize risks and discourage clear identification of them. This kind of attitude gets the project in trouble if the risk events materialize, something that is likely to happen in a large project. Not surprisingly, then, risk management is considered first among the best practices for managing large software projects. Risk management. Risk management aims to identify the risks and then take actions to minimize their effect on the project. Risk management is a relatively new area in software management. It first came to the forefront with Boehm's tutorial on risk management. Before we discuss risk in the software context, let us examine the concept a bit more with the aid of an example. Consider a computer show for which an important goal is to provide uninterrupted computer services. For this goal, one clear risk is electric power failure. The power may or may not fail. If it does fail, even for a second, the computer services will be affected substantially. That is, the machines will have to reboot, data will be lost, and so on. If this case is unacceptable, that is, if the cost of the power failure is high, an uninterrupted power supply, that is UPS, can be deployed to minimize its consequences. If it is suspected that the power may go out for a long period, a backup generator may be set to minimize the problem. With these risk management systems in place, if the power does go out even for a long period, the show-related goal will not be compromised. The first thing to note from this example is that risk management entails additional cost. Here, the cost for the UPS and the generator is extra because these components would not be needed if the risk of power failure did not exist. For example, if the electricity supply company guaranteed continuous power. Hence, risk management can be considered cost-effective only if the cost of risk management is considerably less than the loss incurred if the risk materializes. Actually, the cost of risk management should be less than the expected value of the loss, a concept defined shortly. For example, if the loss due to power failure is low, the cost of a UPS is not justified a situation that prevails, for example in home. Second, it is not easy to measure the value of risk management, particularly in hindsight. If the power fails for 1.5 hours during the show, the value provided by the UPS and generator might be calculated as the savings achieved by having the computers running while the power was out. Suppose, however, that the power supply does not fail even for a second and therefore the UPS and generator are not used. Does this mean that the expenditure on these components was a waste? No, because the power could have failed. If the risk does not materialize, the value of using risk management cannot be directly measured in terms of value or output produced. Because risk events likely or infrequently, the chances are high that risk management systems will not be used during the project. It is this probabilistic nature of risks and the inability to always realize the direct value of risk mitigation efforts that make it difficult to manage risk. From this example, it is clear that the first step in risk management is to identify the possible risk, that is a power failure in this example, and to assess the consequences, that is loss of phase or clients. Once you have done risk assessment, you can develop a risk management plan, for example, having a UPS. Overall, then, risk management has two key components: risk assessment and risk control. The purpose of the risk assessment task is to identify the risks, analyze them, and then prioritize them. In prioritizing risk, you identify the risk that should be managed. In other words, prioritization determines where the extra effort of risk management should be spent to get the maximum benefit. For this effort, two factors are important. First is the chance of a risk occurring. A more likely risk is a natural candidate for risk management. Second is the effect of the risk. A risk whose impact is very high is also a likely candidate. One way to prioritize risks, therefore, is to estimate the probability of its occurrence and its consequences when it does occur. The product of these values, the expected value of the loss for the risk, can be used for prioritization. This expected value is called risk exposure. If probability of R is the probability of a risk R occurring and if loss of R is the total loss incurred if the risk materializes, then risk exposure, that is RE for the risk, is given by the following equation. RE of R is equal to probability of R into loss of R. Once the risks have been prioritized, you must decide what to do about them. Which one will be managed is a management decision. For example, if new hardware is a risk, it could be avoided by implementing the project with proven hardware. Such actions, however, are not always feasible. For example, if working with new hardware is a requirement from the customer, the activities for risk management are combined into two tasks: risk assessment and risk control. Risk assessment. In this video, we are going to see about risk assessment. Risk assessment. In a project at Infosys, risk assessment consists of the two traditional components: risk identification, risk prioritization. Risk identification. For a project, any condition, situation, or event that can occur and would jeopardize the success of the project constitutes a risk. Risk prioritization. The identified risks for a project merely give the possible events that can hinder it from meeting its goals. Usually, little historical data are available to help you make a quantitative estimate of these parameters. Because risks are probabilistic events, they occur infrequently, and that makes it difficult to gather data about them. Furthermore, any such data must be interpreted properly because the act of managing the risks affect them. This fact implies that risk prioritization will be based more on experience than on hard data from the past. In this situation, categorizing both the probabilities and the consequences can serve to separate high priority risk items from lower priority items. At Infosys, the probability of a risk occurring is characterized as low, medium, or high. Gives the probability range for each of these categories. To rank the effects of a risk in a project, you must select a unit of impact. To simplify risk management, Infosys project managers rate the risk impact on a scale of 1 to 10. Within this scale, the risk effects can be rated as low, medium, high, or very high. Gives the range for the consequences for each of these ratings. With these ratings and ranges for each rating in hand, the following simple method for risk prioritization can be specified. For each risk, rate the probability if it's happening as low, medium, or high. For each risk, assess its impact on the project as low, medium, high, or very high. Rank the risks based on the probability and efforts on the project. For example, a high probability, high impact item will have higher rank than a risk item with a medium probability and high impact. Select the top few items for mitigation and tracking. Risk control. In this video, we are going to learn about risk control. Risk control. Once a project manager has identified and prioritized the risks, the question becomes what to do about them. Knowing the risk is of value only if you can prepare a plan so that their consequences are minimal. That is the basic goal of risk management. You minimize the effects of risk in the second step of risk management, risk control. Essentially, this step involves planning the risk mitigation followed by executing the plan and monitoring the risks. Risk management planning. Once risks are identified and prioritized, it becomes clear which risk a project manager should handle. To manage the risk, proper planning is essential. The main task is to identify the actions needed to minimize the risk consequences, generally called risk mitigation steps. As with risk identification, you refer to a list of commonly used risk mitigation steps for various risks and select a suitable risk mitigation step. The list used at Infosys appears in Table. This table is a starting point not only for identifying risk but also for selecting risk mitigation steps after the risks have been prioritized. As with identification, you are not restricted to steps mentioned in Table. You can use the process database to identify the risk and the risk mitigation steps. Most of the risk and mitigation steps in Table 3 are self-explanatory. As you can see, the top few risks are concerned with manpower and requirements. Many of the items here are similar to those in the top risk list given by Boehm Hall. Selecting a risk mitigation step is not just an intellectual exercise. The risk mitigation step must be executed and monitored. To ensure that the needed actions are executed properly, you must incorporate them into a project schedule. In other words, you must update the project schedule, which lists the various activities and specifies when they will occur to include the actions related to the chosen risk mitigation steps. Risk monitoring and tracking. Risk prioritization and consequent planning are based on the risk perception at the time the risk analysis is performed. The first risk analysis takes place during the project planning, and the initial risk management plan reflects a view of the situation at that time. Because risks are probabilistic events frequently depending on external factors, that threat due to risk may change with time as factors change. Clearly, then, the risk perception may also change with time. Furthermore, the risk mitigation steps undertaken may affect the risk perception. This dynamism implies that risks in a project should not be treated as static and must be reevaluated periodically. Hence, in addition to monitoring the progress of the planned risk mitigation steps, you must periodically revisit the risk perception for the entire project. The results of this review are reported in each milestone analysis report. You report the status of the risk mitigation steps along with the current risk perception and strategy. To prepare this report, you make a fresh analysis to determine whether the priorities have changed. Risk components and drivers. In this video, we are going to see about risk components and drivers. US Air Force pamphlet contains guidelines for software risk identification and abatement. Air Force approach requires that the project manager identify the risk drivers that affect software risk components, performance, cost, support, and schedule. Risk components. Performance risk. The degree of uncertainty that the product will meet its requirement and be fit for its intended use. Cost risk. The degree of uncertainty that the project budget will be maintained. Support risk. The degree of uncertainty that the resultant software will be easy to correct, adapt, and enhance. Schedule risk. The degree of uncertainty that the project schedule will be maintained and that the product will be delivered on time. Impact of each risk driver on the risk component is divided into one of four impact categories: negligible, marginal, critical, catastrophic. Risk characterization table. Risk tracking. In this animation, we are going to learn about risk tracking. What do we track in risk? We track risk intensity, that is exposure, risk location and the time of occurrence, a moving target. Risk is a moving target. It has to be tracked. After mitigation, risks do not go away. The following steps help in tracking risk: phase-end risk reviews, risk audits, risk surveys, project closure reviews, risk-based estimation, risk-based planning. Tracking involves re-evaluation of all the risk attributes. The risk might have changed its attributes. When the team that planned and mitigated a risk evaluates the residual risk attributes, the scales of judgment might have changed. Risks will be underestimated. The doer feels he has done it. Designing the mitigation plan and actually mitigating the risk can be dramatically different. Mitigation brings us closer to risks. From these close quarters, the risks do not look like the risks that were identified. The funnel effect applies. The true risk is seen only during mitigation, and the true colors of perceived risk emerge during mitigation. When we track risk, we track the fusion of risk and risk perceptions. Track risk response plans. In this video, we are going to see about track risk response plans. A more direct job is to track the risk response plans themselves. It is better than they are tracked. Risk response plans compete with the core project plans unless both are integrated. The story of risk response plans is a sad one. Many plans do not take off. Some are abandoned in the early stages, many are stopped en route and or forgotten. Despite these foreclosures, quite a few plans do get completed successfully. During tracking, we collect the following data: number of open risks, number of plans that have not yet started, number of plans in active progress, number of completed plans. Tracking the bigger response audits. Risk audits are conducted to see if the organization takes risks seriously. In addition to tracking the details plans, we audit whether bigger responses come forth from the organization. The bigger responses can be tracked at 5 levels of the organization against the results expected. This is a management audit on risk responses. A bird's eye view comparison of expected responses against actual responses tells us how well the organization is responding to risks in real life. Tracking hazard risks. In this video, we are going to see about tracking hazard risks. The hazard risk must be tracked in earnest. We can apply the continuous risk monitoring method to this class of risk. Whether we track other risks or not is less important. Track the following responses to hazard risks. Trigger levels. When we decide to watch risk instead of mitigating them, we should design risk triggers and install them. Triggers are indicators or detectable symptoms. Not every symptom is detectable. Risks exist even before they are identified and elude identification. Some risks are not known until they crystallize and connect with more tangible symptoms. Designing a risk trigger system allows us to plan a progressive series of response. Triggers can be put on metrics or subjective understanding. We need to recognize a trigger and fix threshold levels. Vertical trigger levels represents different magnitudes for the same metric. Early levels detect problems when they are small. Later triggers warn of serious risks. Horizontal triggers are designed to act at different points of time. They trace how the problems transform with time. Unmitigated risk decrease success probability continually. Response levels are decided by the project managers, that is PM's, risk management strategy, and in particular risk tolerance attitudes. Let us look at a trigger system for managing a hazard risk in a maintenance project. Case study: how wrong triggers fail risk management. Tracking project risks. In this video, we are going to learn about tracking project risks. Tracking until project ends. Project risks are tracked in accordance with the life cycle model. Identified risks are tracked until the risks are closed or the project is closed. Some risks may have been mitigated. Mitigation may have given some relief to the project team. Other risks may not have been mitigated. Unmitigated risks would have occurred and caused damage. Irrespective of the status, the risks are closed when the project is closed. Milestone risk review. At project milestones, we should review risks and the risk response plans. Each milestone denotes completion of a mini project and presents a natural point of time to track risk. Performance targets and risks. The project team evaluates the chance of meeting performance targets in every performance review. Risks are tracked along with this. The project dashboard will present risk status. Tracking operational risk. In this video, we are going to learn about tracking operational risk. The term operational risk is used to represent risk in repetitive processes in the organization. Some aspects of software maintenance fall under this category. Tracking risk exposure. The time sense for managing operational risk is different from the time sense for managing project risks. Projects are time-bound and operations are repetitive. In operations, risk tracking need not be aligned with any natural life cycle. Each selected risk is mitigated and tracked in its own right. The repetitive nature of operations presents a new mission for tracking. We ask the question, do risks repeat? A companion question would be, if risks do repeat, does the risk exposure fail? Do more risks appear as operational cycles advance? Have old risks been successfully closed, or does the risk story continue? We track the risk count. Even better, we can track the risk exposure number, that is REN or RPN, from FMEA and work with the aim of reducing REN continually. We can push this process of tracking to the extent of placing a control chart on the metric REN and watching trends and anomalies. The REN reads the risk climate of the organization. Risk monitoring and control. In this animation, we are going to learn about risk monitoring and control. Risk monitoring and control. Risk monitoring and control is the process of identifying, analyzing, and planning for newly discovered risks and managing identified risks. Throughout the process, the risk owners track identified risks, reveal new risks, implement risk response plans, and gauge the risk response plan's effectiveness. The key point is, throughout this phase, constant monitoring and due diligence is key to the success. The inputs to risk monitoring and control are risk management plan, risk register, approved changes requests, work performance information, performance report. Risk management plan. The risk management plan is the details of how to approach and manage project risk. The plan describes the how and when for monitoring risks. Additionally, the risk management plan provides guidance around budgeting and timing for risk-related activities, thresholds, reporting formats, and tracking. Risk register. The risk register contains a comprehensive risk listing for the project. Within this listing, the key inputs into risk monitoring and control are bought into, agreed to, realistic and formal risk responses, the symptoms and warning signs of risk, residual and secondary risks, time and cost contingency reserves, and a watch list of low priority risks. Approved change requests. Approved change requests are the necessary adjustment to work methods, contracts, project scope, and project schedule. Changes can impact existing risk and give rise to new risk. Approved change requests need to be reviewed from the perspective of whether they will affect risk ratings and responses of existing risks, and or if a new risk is a result. Work performance information. Work performance information is the status of the scheduled activities being performed to accomplish the project work. When comparing the scheduled activities to the baseline, it is easy to determine whether contingency plans need to be put into place to bring the project back in line with the baseline budget and schedule. By reviewing work performance information, one can identify if trigger events have occurred, if new risks are appearing on the radar, or if identified risks are dropping from the radar. Performance reports. Performance reports paint a picture of the project's performance with respect to cost, scope, schedule, resources, quality, and risk. Comparing actual performance against baseline plans may unveil risks which may cause problems in the future. Performance reports use bar charts, S-curves, tables, and histograms to organize and summarize information such as earned value analysis and project work progress. All of these inputs help the project manager to monitoring risks and assure a successful project. Once the risk owner has gathered together all of the inputs, it is time to engage in risk monitoring and controlling. The best practices provided by PMI are risk reassessment, status meetings, risk audits, variance and trend analysis, technical performance measurement, reserve analysis, risk reassessment. Risk reassessment is normally addressed at the status meetings. Throughout the project, the risk picture fluctuates. New risks arise, identified risks change, and some risks may simply disappear. To assure team members remain aware of changes in the risk picture, risks are reassessed on a regularly scheduled basis. Reassessing risks enables risk owners and the project manager to evaluate whether risk probability, impact, or urgency ratings are changing. New risks are coming into play, old risks have disappeared, and if risk responses remain adequate. Status meetings. Status meetings provide a forum for team members to share their experience and inform other team members of their progress and plans. A discussion of risk should be an agenda item at every status meeting. Most people find it difficult to talk about risk, however, communication will become easier with practice. To assure this is the case, the project manager must encourage open discussion with no room for negative repercussions for discussing the negative events. Risk audits. Risk audits examine and document the effectiveness of planned risk responses and their impacts on the schedule and budget. Risk audits may be scheduled activities documented in the project management plan, or they can be triggered when thresholds are exceeded. Risk audits are often performed by risk auditors who have specialized expertise in risk assessment and auditing techniques. To ensure objectivity, risk auditors are usually not members of the project team. Some companies even bring in outside firms to perform audits. Variance and trend analysis. Variance analysis examines the difference between the planned and the actual budget or schedule in order to identify unacceptable risks to the schedule, budget, quality, or scope of the project. Earned value analysis is a type of variance analysis. Trend analysis involves observing project performance over time to determine if performance is getting better or worse using a mathematical model to forecast future performance based on past results. Technical performance measurement. Technical performance measurement, that is TPM, identifies deficiencies in meeting system requirements, provide early warning of technical problems and monitor technical risks. The success of TPM depends upon identifying the correct key performance parameters, that is KPPs, at the outset of the project. KPPs are factors that measure something of importance to the project and are time or cost critical. Each KPP is linked to the work breakdown structure, that is WPS, and a time or cost baseline may be established for it. The project manager monitors the performance of KPPs over time and identifies variances from the plan. Reserve analysis. Reserve analysis makes a comparison of the contingency reserves to the remaining amount of risk to ascertain if there is enough reserve in the pool. Contingency reserves are buffers of time, funds, or resources set aside to handle risks that arise as a project moves forward. Contingency reserves are depleted over time as risks trigger and reserves are spent to handle them. With constraints as above monitoring the level of reserves to assure the level remains adequate to cover remaining project risk is a necessary task. Outputs of the risk monitoring and control process are produced continually, fed into a variety of other processes. In addition, outputs of the process are used to update project and organizational documents for the benefit of future project managers. The output of risk monitoring and control are updates to the risk register, updates to organizational process assets, updates to the project management plan, recommend corrective actions, recommend preventative actions, request changes, updates to the risk register. An updated risk register has the outcomes from risk assessments, audits, and risk reviews. In addition, it is updated with the resulting outcome of the project risk and risk response. Was it a good response? Did the response have the desired effect? The updated risk register is a key part of the historical record of risk management for the project and will be added to the historical archives. Updates to organizational process assets. Organizational process assets should be documented in light of the risk management processes to be used in future projects. Updates to the project management plan. Updates to the project management plan occur if any approved changes have an impact on the risk management process. In addition, these authorized changes incur risks which are documented in the risk register. Recommend corrective actions. Recommend corrective actions consists of two types: contingency plans and workaround plans. A contingency plan is a provision in the project management plan that specifies how a risk will be handled if that risk occurs. The plan may be linked with money or time reserves that can be used to implement the plan. A workaround plan is a response to a negative risk that was passively accepted or not previously identified. Recommend preventative actions. Recommended preventative actions assure the project follows the guidelines of the project management plan. Requested changes. Requested changes are any identified changes to the project management plan. change requests are completed and submitted to the integrated change control process. All requested changes must be documented and that approvals at the right management levels are sought and obtained. Risk mitigation and management. In this video, we are going to see about risk mitigation and management. Risk mitigation and management. The goal of the risk mitigation, monitoring and management plan is to identify as many potential risks as possible. When all risks have been identified, they will then be evaluated to determine their probability of occurrence and how it will be affected if they do occur. Plans will then be made to avoid each risk, to track each risk to determine if it is more or less likely to occur, and to plan for those risks should they occur. It is the organization's responsibility to perform risk mitigation, monitoring, and management in order to produce a quality product. The quicker the risk can be identified and avoided, smaller the chances of having to face that particular risk's consequence. The fewer consequences suffered as a result of good RMMM plan, the better the product and the smoother the development process. Risk management organizational role. Each member of the organization will undertake risk management. The development team will consistently be monitoring their progress and project status as to identify present and future risks as quickly and accurately as possible. With this said, the members who are not directly involved with the implementation of the product will also need to keep their eyes open for any possible risks that the development team did not spot.